Hey everybody, we have made it to notes number 33. Can you believe it? And if you recall last time, we talked about finding exact values for trig functions that were multiples of 90, so the quadrantal angles. And you're going to be so excited to hear that today we're going to learn how to do more exact values. I thought you'd feel that way. And even better, next time we're going to learn how to do even more exact values. Okay, so let's get to it. So the basis of what we're doing today is the 30, 60, 90 triangle. And I'm hoping that you learned about this in geometry. So let me just give you the background. If you had an equilateral triangle, so all three sides are the same length, and all three angles are the same, so it's also equiangular, so they measure 60 degrees. And let me just say, let's imagine that the sides have length 2x, 2x, and 2x. It could be anything. And then suppose that you drop a perpendicular from one vertex across to the opposite side. It turns out that that perpendicular is also a bisector. It bisects the opposite side, and it also bisects the angle just because of the symmetry we have in the situation. So now if I take just 1/2 of that figure, so maybe I take this side here, I have a triangle which has a 90-degree angle and a 60-degree angle, so the other one must be 30. So this is a 30, 60, 90 triangle. And because the perpendicular bisected the side, we have two segments that have length x. So down here we have an x. On the hypotenuse we have a 2x. And then if I use the Pythagorean theorem to find the length of the other leg, I get that it is x square root 3. I'm not going to take the time to work through that right now, but you could check that and see. So this means that every 30, 60, 90 triangle has sides in the ratio x, 2x, and x square root 3, where 2x is the longest. So the short leg is half the hypotenuse, and the long leg is the short leg times square root 3. So short is across from the 30-degree angle, long leg is across from the 60-degree angle, and hypotenuse is across from the 90-degree angle. So what I like to do is use what I would call the unit 30, 60, 90 triangle, where you have a 1 on the short leg, you have then a 2 on the hypotenuse, and a square root 3 on the long leg. So this is the 30, 60, 90 triangle I'm going to be using all day today. No matter if it's oriented differently, like it could be turned like this, it doesn't matter. The sides will be in the ratio 1 to square root 3. Okay, so here's what we're going to do next. We're going to find the exact values for the 30-degree angles, starting in quadrant 1. If you have a 30-degree angle, here's the initial side, here's the terminal side, 30 degrees. Put a point on the terminal side, drop a perpendicular to create a reference triangle. And because that triangle is 30, 60, 90, put a 1 on the short leg, a 2 on the hypotenuse, and a square root 3 on the long leg. Now based on that, we can find the sine, cosine, tangent, etc. So I'm going to fill in this row down here. The sine of 30 degrees, opposite over hypotenuse, 1/2. Look at the triangle and you see opposite 1, hypotenuse 2. The cosine of 30 degrees, adjacent over hypotenuse, square root 3 over 2. The tangent of 30 degrees, opposite over adjacent, 1 over square root 3, but 1 over square root 3 can be rationalized and it's square root 3 over 3. You can say radical 3 over 3 if you don't like to say square root. Cosecant of 30 degrees is the reciprocal of sine, so that would be 2. Secant of 30 degrees is the reciprocal of cosine, so if we have 2 over square root 3, and we rationalize it, we get 2 square root 3 over 3. And then cotangent of 30 degrees is the reciprocal of tangent. So instead of opposite over adjacent, we have adjacent over opposite. So we have square root 3 over 1, so it's just square root 3. They're all positive in quadrant 1. Now, in quadrant 2, if you happen to have a reference triangle that has a 30-degree angle, then you're going to get the same values. So how would you get a reference triangle with a 30-degree angle? That would be if your angle that you're interested in, your theta, is 150 degrees. Because the straight line is 180, so if you go 150, you're going to have 30 degrees left to go. So we have our 30-degree reference angle, and then in the triangle we have a 1 for the short leg. I'm going to put negative square root 3 for the long leg. The negative indicates the direction, and then 2 on the hypotenuse. So the sine of 150 degrees is 1/2, opposite over hypotenuse. The cosine is negative square root 3 over 2, adjacent over hypotenuse. The tangent is negative 1 over square root 3, so that's going to be negative square root 3 over 3. The cosecant is hypotenuse over opposite, positive 2. The secant is hypotenuse over adjacent, so 2 over negative square root 3, and that's going to rationalize to be negative 2 square root 3 over 3. And the cotangent is going to be adjacent over opposite, negative square root 3 over 1. So notice that if you compare the first row of numbers and the second row of numbers, the only thing that has changed is some of them are now negative. And remember, all students take calculus. That was all positive, sine positive, tangent positive, and cosine positive. So here we are in quadrant 2 where sine is positive. So notice that we got a positive value here. And then also the reciprocal of sine is positive and everything else is negative. So now let's take a look at quadrant 3. So if you were to have a 30-degree reference angle in quadrant 3, that means that your angle that you went through, starting in standard position, is 210 degrees. So here, this would be the initial side, this would be the terminal side. So we have our 30, 60, 90, so let's put a 1. Actually, let's make it a negative 1 on the short leg. Negative because we're going down to keep the direction in mind. Negative square root 3 on the long leg and 2 on the hypotenuse. So now we find all of the exact values for 210. If you are figuring this out and you just want to go ahead and pause and figure them out yourself, you can, and then resume and see how you did. So sine opposite over hypotenuse would be negative 1/2. Cosine adjacent over hypotenuse, negative square root 3 over 2. Tangent opposite over adjacent, negative over negative is positive. 1 over square root 3 is going to rationalize to square root 3 over 3. And then we have our reciprocals, negative 2 square root 3 over 3, and square root 3. Notice that the positives are tangent and its reciprocal, because in quadrant 3, remember, all students take calculus, tangent is positive, and so is its reciprocal. Okay, now let's do quadrant 4. So in order to have a 30-degree reference triangle in quadrant 4, that means we must have gone how many degrees? All the way around to what? That's right, 330. So this is going to be our reference triangle for the 330-degree angle. So let's put our numbers, negative 1, square root 3, and 2, and the sine will be negative 1/2. The cosine will be positive square root 3 over 2. The tangent will be negative square root 3 over 3. The cosecant will be negative 2. The secant will be positive 2 square root 3 over 3. And the cotangent will be negative square root 3. So cosine is positive in quadrant 4, and so is its reciprocal, and everything else is negative. So now, anytime you want to find an exact value for one of these angles, 30, 150, 210, and 330, you always use the 30, 60, 90 triangle with a 30-degree reference angle. Notice that the reference angle is always the angle made with the horizontal. It's never the angle made with the vertical, so it's not this, okay? It's not that. It's the angle made with the horizontal, like so. All right, so now let's go on and do the exact same thing for multiples of 60. So exact values for 60-degree reference angles. We're back in quadrant 1. And so if we have a 60-degree angle, drop a perpendicular. You have a 30, 60, 90 triangle, same as we did before, but the orientation is different. So the long leg is down here, or excuse me, the short leg is down there across from the 30, and the long leg is over there, and the hypotenuse is still 2. So the sine would be square root 3 over 2. The cosine would be 1/2. The tangent would be square root 3, because it's square root 3 over 1. And then for the reciprocals, we're going to get 2 square root 3 over 3. We're going to get 2, and we're going to get square root 3 over 3. And then for quadrant 2, the way you would have a 60-degree reference angle for a 60-degree reference triangle is if your angle that you were interested in here was 120. So with the 30, 60, 90 triangle, you have your 1 on the short leg, your square root 3 on the long leg, and your 2 on the hypotenuse. But let's make it a negative 1 since we went left. So the sine is going to be square root 3 over 2. The cosine is negative 1/2. The tangent is negative square root 3. The cosecant is 2 square root 3 over 3. The secant is negative 2, and the tangent, or the cotangent, is negative square root 3 over 3. Okay, so let's do quadrant 3 and quadrant 4. Quadrant 3, the way you would have a 60-degree reference angle and a 60-degree reference triangle is if the angle you were interested in was how much? Half a circle plus 60, that would be 240 degrees. So this is how you get all the exact values for 240. You put your 1, make it a negative, you put your square root 3, make it a negative, and then your 2. So the sine is going to be negative square root 3 over 2. The cosine is going to be negative 1/2. The tangent is going to be positive because it's negative over negative. And then the reciprocals, we get negative 2 square root 3 over 3. We get negative 2, and we get positive square root 3 over 3. And then for quadrant 4, 60-degree reference angle. See, I'm being a little sloppy, and my triangle might not look 30, 60, 90, but when you label it, that's what it is. So the 1 goes here, the square root 3 is negative because we're going down, the 2 on the hypotenuse, and here we go. The sine is going to be negative square root 3 over 2. The cosine is positive this time, positive 1/2. Tangent is negative. Cosecant is negative. Secant is positive, and cotangent is negative. Now, I'm getting these quickly because I'm looking up at what I had above and just making it positive or negative. But when you're doing these problems, you're not going to be looking at a chart of all of the different numbers that you've already figured out. So you'll just do it by drawing the picture, drawing the triangle, labeling it, and finding the one you need. So let's practice that. Suppose we want cosecant of 150. Okay, so where's 150? Let's draw the angle. Here's the initial side. Here's the terminal side. This is 150 degrees. So what we have left is 30 degrees. So that tells us that we have a 30, 60, 90 triangle. 30 is the reference angle. Across from 30 is 1. On the adjacent, we'll put negative square root 3, and on the hypotenuse, we'll put 2. Now that we have it labeled, our job is to find the cosecant. Cosecant is reciprocal of sine. So instead of opposite over hypotenuse, we have hypotenuse over opposite. We have 2 over 1, and that just reduces to 2. So that's how you do it when you just have a single problem in isolation. Just figure it out for that one. Number 2, sine of 60 degrees. So where's 60 degrees? It's in quadrant 1. Draw the angle, drop a perpendicular. You have your reference triangle. Across from 60 is square root 3. Across from 30 is 1. 2 on the hypotenuse. And the sine is opposite over hypotenuse, so that would be square root 3 over 2. See, it really doesn't take that long to figure these out once you get on a roll. Now I'm mixing things up. Cosine of 270. Aha, 270. Think back to last time. 270, if you start here and go around, you actually end here. So that is not going to be a reference triangle problem. That's going to be a unit circle problem. I'm mixing them in, the ones from last time and the ones from this time. So on the unit circle, you can draw a circle if you want to. You don't have to draw the circle. I usually just imagine the circle. This is the point 0, negative 1. Remember, cosine is the x, sine is the y, so our answer is 0. And then number 4. Okay, this one's not quadrantal, so we're back to doing reference triangles. To get to 300 degrees, you would start here, go all the way around into quadrant 4. How many degrees do you have left to go to make it around the circle? 60. So this is a 30, 60, 90. Square root 3 goes on the opposite with a negative, 1 on the adjacent, 2 on the hypotenuse. Now we're ready to think about cotangent. Cotangent is adjacent over opposite, so 1 over negative square root 3. Rationalize that and we get negative square root 3 over 3. So, in your homework today, you're going to be doing a bunch of problems like that where you draw the picture and you label it and you figure it out. Last thing I want to teach you is how to do this backwards. So, what happens if you know the exact value and you're looking for the angle? Find all the values of theta in the interval between 0 and 360 degrees that satisfy this equation. Okay, so for number 5, we want the cosine of theta to be negative 1/2. So you ask yourself, where is cosine negative? Well, they're all positive in 1. Cosine is positive in 4. Cosine is negative in quadrants 2 and 3. So let's draw a reference triangle in quadrant 2. Doesn't matter if it's to scale. Let's draw a reference triangle in quadrant 3. Those should look congruent. Sorry, it was sloppy. If the cosine is negative 1/2, that means we should put negative 1 on the adjacent and 2 on the hypotenuse, because cosine is adjacent over hypotenuse. Once you see that, you should go, oh wait, I recognize this. If I have a 1 there and a 2 there, I should have a square root 3 there. And if it's down there, it would be negative square root 3. So now we realize, oh, across from square root 3 is a 60. This is a 60-degree reference angle and a 60-degree reference triangle, 2 of them. Okay, so then, what angle was this? Must have been 120. And then the other one, all the way around to here, must have been 240. So our answers are, I should say theta equals 120 degrees or 240 degrees. Now let's do that again for the next one. The cotangent of theta is negative square root 3 over 3. Now wait a second. We've seen this number before, but we didn't have a triangle that had sides with, say, square root 3 and 3, did we? No, we had a triangle with sides 1, 2, and square root 3. So what I'm going to do is I'm going to actually take this ratio and unrationalize it. What was it before it was rationalized? It was negative 1 over square root 3. How do I know? Experience. We just did a whole bunch of problems, I think like 92,000 of them, where we used these numbers. So, unrationalize it, and now you're ready to go. Where is cotangent negative? Cotangent is negative in quadrant 2 and quadrant 4. So reference triangles, and then cotangent is adjacent over opposite, so put the 1 on the adjacent and the square root 3 on the opposite. Same thing in quadrant 4. Now when you're in quadrant 2, you want the negative on the 1, and when you're in quadrant 4, you want the negative on the square root 3. So the hypotenuse is 2, and across from the square root 3 would be our 60-degree angle. Notice we have the same reference triangle we had in number 5. Sorry, I probably should have made that different. That's okay. So that means this angle right here is 120 degrees, so that's one of our answers. And then all the way around to here would be 300 degrees. So that's another one of our answers. So theta equals 120 degrees or 300 degrees. Okay. So you have a worksheet, exact values practice sheet number 1. You're going to be drawing the pictures and finding the values using 30, 60, 90 triangles or using the unit circle. And then a few problems from page 528 where you're working backwards like the ones we just did. Now when you do the practice sheet, you need to draw the picture and figure it out just like I showed you. Don't use a calculator. And you can check your answers with your notes, but I've also provided you with the answer key. Thanks everybody.